Second derivatives. Sometimes we need to take the derivative of the derivative, and that's called a second derivative. And these are all the notations. Let's look at an example using this prime notation. If we have y equals 5x to the fourth, and we're asked to find y prime, well, we just take the derivative of 5x to the fourth, and we get 20x cubed. We might be asked to take the second derivative. That is, we might be asked what y double prime is. This is read y double prime because there's two prime symbols there. And so y double prime would be equal to, well, we take the derivative of 20x cubed. 20 times 3 is 60, so we get 60x squared. One use of this prime notation, y prime, and y double prime, is in differential equations. Here's a differential equation. It's just an equation with derivatives in it. It's y double prime squared minus 720 times y is equal to 0. Later on, if you take differential equations, you might be asked to solve a differential equation like this. In this case, we're already given the solution. Y equals 5x to the fourth. We're supposed to show y equals 5x to the fourth satisfies this equation. To do that, well, we need to figure out what y double prime is. We have it right here. So we take the 60x squared and we plug it in for y double prime. So we have 60x squared minus 720. In for y, we put 5x to the fourth. That's all this means. It means take this expression for y, plug in the second derivative, and plug in the function. And now we just take this expression and simplify it. 60x squared is 3600 x to the fourth. 720 times 5x to the fourth is 3600 x to the fourth. And sure enough, they cancel out and give us 0. That equation is satisfied by that function. Let's look at this notation a little bit more carefully. This d2 dx2 fx, second derivative of f of x. Let's use that notation to find the first and second derivatives of y equals x to the minus 2 to see if we can't dissect that a little bit. Well, the first derivative is easy. d dx of x to the minus 2 is just minus 2x to the minus 3. Let's look at the second derivative of x to the minus 2 in that notation. We would write it down as d squared over dx squared of x to the minus 2. And one way of looking at this symbol d squared over dx squared is it says to take d dx of another d dx of x to the minus 2. That is, those squared symbols means, well, we have d squared, we have two d's, dx squared, we have two dx's. That's one way of interpreting that symbol. It says apply this d dx operator twice. First find d dx of x to the minus 2, and we can do that. It's minus 2x to the minus 3. And then we take d dx of that minus 2x to the minus 3 to find the second derivative. So we found the derivative of x to the minus 2, that was minus 2x to the minus 3. And then we find the derivative of minus 2x to the minus 3. Minus 3 times minus 2 is 6. We get 6x to the minus 4. So these are some of the ways that we can use different notations for second derivatives in solving different equations and finding different derivatives.